All right, so today we're doing note special trinomial factoring. Now, the deal with special trinomial factoring is that these are just tricks and shortcuts to factor certain types of polynomials, well, quadratics in our sense. Okay. However, you can do what we did last week, 5A and 5B, for these problems. Again, these are just some tricks and shortcuts for factoring. Do you have to do them? No, you do not. But they're here because someone recognized the pattern and created a rule for you to follow. Okay. So first, we're going to talk about perfect squares. Can someone tell me what a perfect square is?
90%. 90%. Degrees, yes, degrees.
That's perpendicular.
It's if you were to square root it, it'll hold you.
Okay, yes, exactly. That's better than I've gotten all day. If you were to square root the number, you would get a whole number, right? Essentially, what a perfect square is a number whose factors are the same number. Meaning that I have a number times itself, and the product is another number. So therefore, my perfect square is 1. If I had 2 times 2, the perfect square is 4. If I had 3 times 3, the perfect square is 9. Okay, we call them perfect squares because the dimensions, well, the factors could be the dimensions of a square. Does that make sense? Okay. I don't know why this question has gone over everyone's head today. I'm a little concerned about geometry and algebra 1. Not sure how you left those classes not knowing what perfect squares are. But at this point, you should be able to know your perfect squares at least up to your 12. Okay. But these 3 are our smallest 3 perfect squares, right? And the rest just keep going. Again, perfect squares are, the factors are the same number. So yes. Now, perfect square trinomials. So if your coefficient A and C are both perfect squares, so if A and C are both perfect squares, then you can check to see if your coefficient B, the middle term, is double their product. And if that's the case, then it simply factors into what's called a perfect square trinomial, which means that it's just the square root of your A and your C added or subtracted and squared together. Okay. Again, do you have to utilize this method? No, because you can do it without it. All right. So we're going to do both. We're going to do it with the method, the new one today, the shortcut, and then we're going to do with what you learned last week. Okay. So looking at what I have my A term, my B term, and my C term, right? When I look at my A, my B, and my C, just right off the bat, 4x squared and 36, are those perfect squares?
No.
Yes, they are. 6 times 6 is 36. 2 times 2 is 4. So therefore, these are perfect squares. Because they're perfect squares, that means that I can take the square root of the A term and I get 2x. I can take the square root of the C term and I get 6. Okay. Now, if this is a quick short factoring where I don't have to do X box and I don't have to do branches or anything, then the middle term, this B, 24x, would equal double the product. So the product of 2x and 6. Is this a true statement? Does 24 equal double the product of my A and my C term? Yes, it does. And because of that, that means that the factor of this is 2x plus 6 squared. This is not fully factored. Why is it not fully factored? There's still a GCF, right? And what is the GCF? 2. I can still divide everything by 2. So when I divide everything by 2, it is just not 1, 2. It's actually 2 squared which means fully factored, I'm at x plus 3, 4 times x plus 3 squared. And we utilize the first rule to check where it's positive 2 because it's a plus and a plus. When you have numbers inside of a parenthesis, the power applies to everything. So if I have 2x plus 6 squared, if I'm factoring anything out of it, whatever I factor out also has to be squared.
Can you do that when it's like, if it were like 2x plus 6, like 3x plus 2?
Okay. And the reason why you square is because 2x plus 6 squared means you have 2 of those, not just one. So you have to account for the fact that it would be 2 times 2. All right, so this is the shortcut method. Now, following what you did, your notes from last week, we're gonna do it the classic way. First thing you do is you identify a GCF. Is there a GCF in the original? Yes, the GCF is 4. I can divide everything by 4. And my quotient that I'm left with is 4 times x squared plus 6x plus 9. Then I ask myself what multiplies to give me 9, but adds to give me 6. And the reason why I can do a simple is because my leading coefficient is 1. So I don't have to do the full on X box, just gotta ask myself, what multiplies to give me 9, but adds to give me 6? 3. 3 times 3. 3 times 3 and 3 plus 3. So therefore, this is 4 times x plus 3 times x plus 3. So my factor is 4 times x plus 3 squared. Do I still get the same answer? Yes. So the red is deemed as a mental shortcut. The purple is your symbolic representation that you would do out on paper. Okay, am I making you do the red? No, I'm just showing you that it's a possibility, okay? Okay, so we're gonna do this again. We're gonna do another example. We're gonna do an example with the shortcut, and then we're gonna do an example with the classic way, okay? So here we have 64x squared minus 16x plus 1, okay? So identifying my A and my B, are they perfect? My C, are they perfect squares? Is 64x squared perfect? Yes, 64x squared is perfect. That's because I can take the square root of it and I get what? 8x. Okay. 1 is perfect because I can take the square root of it and I get 1. Yes. Okay. So to see if this works and I can save myself some time, my goal is to test to see, does negative 16x equal double the product of 8x and 1? Does it equal that? Yes, negative 2 times 8 is negative 16x. So therefore, my factor is 8x minus 1 squared. And I'm done. I made it a negative because the 16 is negative because you're subtracting. Good question. Okay. Now we're going to do this the classic way. So the classic for this would be either Xbox or grouping, whichever one you prefer. I'll do Xbox. So with Xbox, you have your A times your C, which is 64x squared. And you have negative 16, which is your B. You're looking for what multiplies to give you 64x squared, but adds to give you negative 16. What two numbers do that? What two numbers will multiply to give me a positive 64, but add to give me a negative 16? Negative 8 and negative 8, right? And I need x squared. So if you wanted to go ahead and throw your x's in there now, you could, or you can wait till you get to the box. Okay. If you did not do your 5.5b notes on Friday, you may be a little lost. In the first box is your first term, so always your A. Last box is your last term, which is always your C. Your middle are the numbers that satisfy the x, which is negative 8x, negative 8x. When you're going around the box, you're taking the GCF of each row and the GCF of each column. So the GCF of this row is 8x. The GCF of this row is negative 1. The reason why it's negative is because the outside box is negative. The GCF of this column is 8x. The GCF of this column is negative 1. And it's negative because the outside box is negative. So therefore, your factors are 8x minus 1 times 8x minus 1, which means that it is 8x minus 1 squared. So someone did this enough time to recognize that there's a pattern. And they did this enough time to see, wait, hold up. Guys, every time we do this, we get the square root of our A term and the square root of our C term. And then that's where the rule came into play. If you aren't comfortable with the rule or don't want to memorize the rule, what do you have? You have the option to do Xbox or grouping, whichever one your heart tells you to do. Okay. Again, if you did not take your notes on Friday for 5.5b, you may want to consider going back and doing so. All right. So yeah, so that's the shortcut to some of your trinomials. Okay. And it only works if A and C are what? Perfect squares. It only works if A and C are perfect squares. Okay. All right. On the back, method number 7, difference of two squares, dots. All right. For dots, what it means when it says difference means that something's being subtracted, right? And it says two squares. So that means you have a perfect square here and a perfect square here being subtracted. That's what it means when it says difference of two squares. Okay. When you have difference of two squares, the factoring shortcut is you're going to end up with A minus B times A plus B. No, it does not matter if the plus or minus comes first. These are equivalent, A plus B or A minus B. Yes. Okay, so at the top of your page, you may want to write this. It's written at the bottom, but you want to add it to the top, you can. All right. If you're following along, we're on the back of our notes. If you're not following along and just staring at the screen. All right. So let's put into action. So using your notes from last week, if you had A squared minus 1, you would substitute in 0x for your B. And then you would be asking yourself what multiplies to equal -1, but adds to equal 0. And so you would ask yourself, what two numbers will give me -1 as the product and 0 as their sum? And anyone? -1 and 1. That's because -1 times 1 is -1. -1 plus 1 is 0. So your factors would become x minus 1 and x plus 1. If you could turn these a's to x's, I would greatly appreciate it. I have no clue why I wrote a's. Can't even tell you. Okay, so then your factored form would be x minus 1 times x plus 1. So mathematicians did this enough time to realize, hey, hold up. We don't have to keep substituting in 0 for bx. If we just have x squared minus 1, all we're doing is taking the square root of the a term, taking the square root of the c term, and writing the factors as plus and minus. And that's what we're doing. So with that in mind, what do you think will happen with this one? Are my a term and my c term, are my two terms both perfect squares? Are they being subtracted? So what does that mean I can do? I could just find the square root and then add and subtract their roots. So what's the square root of 9b squared? What's the square root of 4? And I just need to have its opposite. The reason why you need the opposite is because you need the middle term to cancel out, right? And the only way it'll do that is if I have the opposite values. And there it is, fully factored without having to go through the whole thing. Okay, so the rule here again is if the a term and c term are perfect squares, then you factor them by taking the square root of each term and add and subtract the roots. Okay, so we're going to do kind of like a quick out loud class check together. Okay, so the last 4, I want us to kind of, you tell me and I write situation. So we have x squared minus 9. Are they both perfect squares? Are they being subtracted? Yes. So what are my factors? Perfect. X squared minus 3 and x plus 3. Why? Because all we have to do is take the square root of each term. Okay, let's do D, 4. I can talk. D squared minus 121. Are both terms perfect squares?
Yes.
Are both terms being subtracted? So all I have to do is take the square root, and what do you get? D minus 11 and times D plus 11. Good. Okay, 5 is a special case. 5 here, before we do anything, this is an example where you need to find the GCF first. Is there a GCF between these two terms?
Yes.
Yes. What is it? It's actually 9. Okay, a little trick to know if something's divisible by 9. If you add the digits up and it's a multiple of 9, then it's divisible by 9. So 1 plus 4 plus 4 is 9. So that means that this number is divisible by 9. Yeah. So we end up with factoring out 9. We're left with, I know, 16. No, I just lied to you, Jaime. I felt like that would be a good thing to tell you. Okay. So now, still, do the two terms, are the two terms still perfect squares?
Yeah.
Yes, they are. So can we still use a trick? Yes, so I can still use a trick. And we end up with 9 times what?
Times 12.
4. H square root of 16 is 4.
What is 12 times 12?
Okay, if you waited to do the GCF, then you would have to factor it out once you have your perfect squares, which is also fine as long as you remember to do so. All right, last one is to show you that when there's a variable, both variables have to be perfect squares. Are both variables perfect squares?
Yes.
Are both numbers perfect squares?
Yes.
Yes. So can I take the square root?
Yes.
What is the square root of 25k squared? 5k. What is the square root of 64j squared? 8j. Oh, my pen. did some weird things there. And you, oh, still doing it. Okay. I just want to make a parenthesis. Let me try this way. Woof. Okay. And I also have to have it positive. And that is how that shortcut works, that rule. That's how dots works. Questions on either one of the shortcuts? Do you have to use them? No, but they do make your life easier, right? But you don't have to use it. All right.